Today's lesson, 10-3, is on inverse functions. In mathematics, we've talked about inverse things before. We have, let me add a page here and write something about it. We have additive inverses. These are two things that you add together and it equals 0, like -4 and 4, or 13 and -13. Those are additive inverses. Combined, they sort of undo each other, right? -4 and then 4 more, it gets you back to 0. Okay, we also have inverse operations. So addition and subtraction are inverse operations. Subtracting is like undoing addition, or vice versa. Also, multiplying and dividing, those are inverse operations. And we have taking something to the second power or square rooting something. Those are inverse operations as well. So today we're going to talk about inverse functions. And we're going to start by describing inverse relations. An inverse relation, if the relation is written as that, then the inverse relation has that notation, r to the -1st power. And what we're going to do is essentially undo whatever was done before. So if you think of a machine, you put the number 0 into the machine and it kicks out a -7. This would do the opposite. If you put in -7, it would kick out a 0. Okay, so based on what I've written here, there's that point. Here's the one I've put as its inverse. I want you to make a prediction about what the next point would be. They've got -1, 2 listed here. It would be 2, -1. Do you see a pattern? Here we've got -2, -4. It's just writing them in backwards, right? Just changing the order. Okay, so that's the inverse relation. The inverse of a function is written with this notation. That's how we say the inverse of the function. And there are 4 steps to finding the inverse of a function. So the first step is to replace the f of x with y. So essentially we're taking it from function form to standard form. So let me show you on the first example. I would just cross out this f of x and put a y in its place. Example 2, cross out the g of x, put a y. Let's look at step 2. Interchange the x and y. While this is a simple step, it feels kind of strange. So some students might struggle with this, but what we're going to do is just switch. Where the x was, we're putting a y there instead, and where the y was, we're putting an x instead. So we're just swapping those. I invite you to pause here for a second and look at example 2, see if you can make that change, and possibly even example 3. Okay, the third step is now to solve for y, and this is where the bulk of the work comes in. So we've got some algebraic fun to deal with, right? What we're going to do here is undo each of the steps of what's happening. So if we talk about the y here, we could say the y is being multiplied by 7, then having 18 added to it, and divided by 2. What we're going to do is every one of those with the inverse operation going in the opposite order. So to solve this, we're going to start by multiplying by 2, then we're going to subtract by 18, and finally we'll divide by 7. Okay, let me show you algebraically how we do this. So I want to get rid of this denominator, so what I'm going to do is multiply both sides of the equation by 2. If I multiply one side of the equation by something, I have to do the other side, and then it's all fair game. So on the left we get 2x. On the right, this 2 and that 2, they will cancel each other out. 2 times something with a denominator of 2, they just cancel each other away when we simplify, and we're left with 7y plus 18. So over on my chart, I said first I was going to multiply by 2, so I've done that. Then I'm going to subtract 18, because remember my goal is to get y alone. And finally, I'm going to divide by 7. Now I have y equals 2x minus 18 divided by 7. Let's look at step 4. This last step says rewrite as as the inverse function. So we're just going to put it back into function notation. So this will look like, I'm writing that instead of y equals 2x minus 18 all over 7. All right, let's try the next one, following these 4 steps. So first, we changed g of x to y, then we interchanged x and y. Okay, if I want, I could write a list of what's happening right now. Y is being multiplied by 1/3 and has 7 added to it. So I'm going to do the inverse things. I'm going to subtract by 7 and then divide by 1/3. Okay, so let's take a look over here. If I want to get y alone, I would start by subtracting 7 from both sides. Then I could divide by 1/3. Dividing by the 1/3 is the same as multiplying by its reciprocal, 3. So I'm going to rewrite this as though I was doing 3 times x minus 7. Let's go ahead and distribute that. So we'd have 3x minus 21. We got y alone, so I'm just going to jump to the 4th step, which was to rewrite like that. That's a little bit messy. I don't know if that's any better, but there we go. Okay, taking a look at this last one. We're going to swap this out. So we have x equals 4y plus 2 times 4y plus 3. Okay, this one is not easy to draw that map because, excuse me, there are 2 y's, so it's hard to sort of describe what's happening. So I'm not going to use that method, but instead what I want to say is we want to get the variable off of the denominator. So what I'm going to do is multiply both sides of the equation by 4y plus 3. That will have those cancel out. But then over here, we'll take 4y plus 3 times x. And we're going to need to distribute the x to each of those, or each of those terms to the x, either way you want to think about it. So we'll have 4xy plus 3x equals 4y plus 2. Okay, at this point, you want to get all of the y terms on one side of the equation and all of the terms that don't have the variable y on the other side of the equation. So I'm going to start by subtracting 4y. It does not have a like term over here, so I've just got to subtract it someplace else. And while I'm at it, I want to move this 3x. It doesn't have a y, so I want to move it from this side. Doesn't have a like term over there, so I'll move it there. So those cancel out. So we have 4xy minus 4y equals negative 3x plus 2. Okay, we have all the y's on one side. What we'd like to do is isolate it the best we can. So we're going to divide each of these terms by y and then write it as a factored number. 4xy divided by y is 4x. Negative 4y divided by y is negative 4. Okay, we have y, a single y in the whole problem, but 4x minus 4 is being multiplied by it, so we're going to divide. Divide both sides by 4x minus 4. When I do that, 4x minus 4 divided by 4x minus 4, that's just 1. So I'm left with 1y over there, and then there's my answer. So let's rewrite it in function notation. I'm going to sneeze, I think. All over 4x. Excuse me, minus 4. All right. Notice kind of a cool pattern that takes place there between the top and the bottom. All right, last concept that we want to talk about in this lesson is that you can prove that two functions are inverses if you take the composite function and you get the answer x. And the order doesn't matter. You could go f of g of x or g of f of x, and you'd still get x either way if they are inverses. So let's prove this. On this problem, I think it might be easier. Well, either way is actually quite easy. So we'll just do f of g of x. Now, we did a composite lesson yesterday, right? I suggested starting with the inside thing. So what I'm going to do is rewrite g of x as 2x plus 7. So now what I'm looking for is f of 2x plus 7, right? That was g of x. We're just substituting that in there. Now what I'm going to do is write the f function, but everywhere there's an x, I'm going to write 2x plus 7 instead. So here's the f function. Instead of x minus 7, I'm going to write 2x plus 7 minus 7 all over 2. Okay, let's go through our order of operations. Parentheses. Can we simplify inside the parentheses? 2x plus 7? No. Exponents. Don't have any. Multiply or divide. Let's take care of the numerator first, and then we'll do denominator. So on the numerator, we have 2x plus 7 minus 7. That's 2x. The denominator is 2. 2 divided by 2 is 1, so we are left with just x. That means that, yes, these are inverses. Let's look at example 5. Okay, so if we do f of g of x. Okay, we'll start by writing g of x. That's 1/3 x minus 3. We want to find f of that. So I'm going to plug this expression in right there for the x. So we have negative 3 times 1/3 x minus 3 minus 9. Okay, negative 3 times 1/3, that's negative 1x. Negative 3 times negative 3, that's 9. And then we have minus 9 out there. Those two are 0, but I'm not left with just x, I'm left with negative x. So that means no, these are not inverses. All right, give the assignment a try. Good luck.